Hello, hello everybody. Welcome again to Functions, Modeling, and Predicting Change. And so, what we have been looking at over the past week or so is the linear function y equals mx plus b, where m is the slope or the rate of change, and b is your y-intercept, which is your starting amount or your initial value. Okay? And so, here's an example of what a linear function looks like that actually has numbers in it, where y equals 2x plus 1, where 2 is your slope or your rate of change. And of course, as you see, the y-intercept or the starting amount or the initial value is the number 1. And so this is what we learned yesterday. And yesterday we ended the day with writing linear models. And so it's always nice when you're given perfect scenarios, like you see here, that can easily be written and solved using whole numbers or integers. But that is not quite what life is. And oftentimes, life is going to present you with models and linear models at that are not perfectly whole numbers and integers that are easy to use and to work with. And so that's what we're going to be working with today. So what I would like for everybody to do is to open up on Canvas this school consolidation project. And what this is the first part of it, where you're going to determine and help the district to decide which school to close. Okay, so as you open this up, you're going to find that there are different projections that you're going to make. And I'm going to go through the first page with you so you understand what you need to do. Now, don't become overwhelmed that you see this is, oh my goodness, 7 pages of math. Okay, this is not all due in one day. In fact, we've been asked not to have any work for you on Wednesday, which is the day of the science check-in. So this entire thing will be due Friday since they don't want me to work you on Wednesday. Okay, so let's go ahead and get started with how we're going to do this, all right? So I'm going to annotate with Cami. And here we go. All right, so as the document loads, okay, let's go ahead and start with the enrollment projections. And I'm going to do this first page for and with you. And then after that, you should be able to do the other pages yourself, but I am always available for questions. All right. So if you look here at enrollment projections, it says with changing communities and the rise of non-traditional schools, districts are faced with enrollment questions every year. And enrollment is directly tied to the amount of funds that school districts receive from the state and federal government, which impacts how schools plan their finances. Each of the districts are attempting to predict their enrollment for the next year with models. Are the districts growing or shrinking, and by how much? Okay, so if you look here, you have a table of values, and you've got the years 1, 2, 3, 4, and then you've got the numbers of enrollment here. Now, you can use a linear model to predict the change and to make a prediction for what next year is going to be, which is going to be year 5. So what is the easiest way to do this? Okay, well, we learned how to find the rate of change in a table a few days ago. We learned how to find rate of change using the slope formula. We also learned how to find rate of change by rise over run. But today what I'm going to show you is how you can find the linear model using the Desmos calculator and what we call linear regression. Okay, so click on the link for Desmos, and this is what's going to come up. And what you need to do is on a separate sheet of paper, write down these steps as I give them to you, and keep this someplace handy because you're going to use this a lot for the rest of this year. Okay, so let's go ahead and start with our enrollment projections. So come up here to the plus side and click the table. And we're going to input the years as our X values. So I have 1, 2, 3, and 4. And then for my y values, I'm going to input the enrollment numbers. So 13146, 12984, 12754, and 12792. Okay, so that's what your table looks like. Now, the next thing that we want to do is find the linear model, okay, or the linear function. So what you're going to do is come back up here to the plus, and where it says item, click on f of x expression. All right. Now on this next line, or cell, excuse me, we are going to type the linear model. But we're going to type it a little bit differently because you have to understand that we are talking to a computer here. So we have to give it to the computer in computer language. So if you look up here, you have y1. So you're going to type y1. Now, instead of using the equal sign, I want you to look on your keyboard up at the very upper left-hand side of the standard keyboard, and you see a key that says ESC. And then right below it, you see another key that has a tilde at the top of it. So press the shift and press that tilde key, and you should get something that looks like this. Now, what this symbol means in math is that it is approximately equal to or equivalent. Now, understand you're talking to a computer here, and so you're giving the computer a logic statement so the computer knows to compute your rate of change as close as it can get, and you'll understand that in a moment when you see what happens. So you're going to use the tilde key. So y is approximately mx, and then type the 1, and then plus b. Now, look at all the numbers that came up. So the numbers you're going to concern yourself with are the parameters right down here. So you see that m equals a negative 129.2, and that's why you told the computer to use that approximately, or else you would have gotten a much larger number since what we got here was an irrational number. So m, which is your rate of change or your slope, and then b is the y-intercept of 13242. Okay? So what you're going to do then is you're going to take those two numbers, and we're going to go back here because we are modeling and predicting change. So my model is going to be y equals a negative 129.2x, and then plus 13242. Okay? So that's my linear model. Okay? And it might run a little bit over into this box, and that's okay. I mean, you can, make your text larger or smaller if you need to, okay, to make it fit in the box. I have the ability on Canvas to enlarge and increase your text, so I can certainly do that to see what your answers are. So we have y equals a negative 129.2x plus 13,242. So what it says here next is the next year prediction. So all of your next year predictions are going to be a 5 for year 5, because right now you're currently in year 4. This is your linear model that you're going to use to predict year 5. So modeling and predicting change, okay? That's what we do here. So let's go ahead and write the linear function that we have here, which is y equals the negative 129.2x plus 13,242. Now, since we said we're going to use the next year, which is year 5, that is the year we are trying to predict. So what I'm going to do is take this linear model, and then I'm going to make 5 the input, so I can get an output of that value for year 5. So on my calculator, when I do, this becomes a negative 646 plus 13,242. And so when I finish my math here of adding that negative to the positive, I get an answer of 12,596. So my next year prediction then is 12,596. Now, it says over here, interpret the rate of change for the linear model. So what I would do here for my interpretation is I would type the number of students is decreasing by 129 per year. Okay? Now, that's what your rate of change tells you because it's a negative 129.2x. All right, you could also say the number of students is decreasing by approximately 129 per year. And the reason we approximate is because we're talking about human behavior here. And you can never really predict what people are going to do. So we'll just use the approximation. Okay? So then it says, if the superintendent guesses that the enrollment will be 12,900 students in the district, do you believe that is an overestimate or an underestimate? So if your linear model says you're going to have 12,596, he's predicting 12,900, then you would say, I believe this is an overestimate. Okay? And that would be your answer. All right, so let's move on to the next one, Jefferson Unified School District. Okay, so same thing. Let's go over here to Desmos and let's close these and go back to and insert a table. So I've got year 1, 2, 3, 4. And then I've got 1518, 1498, 1531, and 1562. All right, so then I come back up here to the plus, and I press f of x expression, and I'm going to again say y1 approximately mx1 plus b. Okay, so there again, I look down here and see my parameters. So my parameters, m, which is the rate of change, is going to be 16.5. And then my y-intercept is going to be 1486. Okay. So we'll come back over here. So my linear model is going to be y equals 16.5x plus 1486. All right, so again, we want to make a prediction for the next year. So again, this is going to be currently year 4. So my next year prediction is going to be year 5. All right, so again, I'm simply going to input the 5 where x is. Okay, so 1568.5. All right, so we will go back And since we're dealing with people, you can't have half a person, so we'll round up that 1,568.5 to 1,569. Okay, so there again, interpret the rate of change of the linear model. So what I'm going to say here is the number of students enrolling is increasing by 16.5 or 17 if we're going to not count half a person. Okay, so it says here, at a community meeting, the school board announced that they expect the enrollment will be over 1,600 students in the district. Do you believe that is an overestimate or an underestimate? Okay, so you would just type again, what do you believe? Okay, so I believe this is an overestimate. Okay, then, for our last one, Washington Public Schools. All right, so we'll go back to Desmos, same thing. We'll close this. And then for year one, we'll put in the 71,319, 73,190, 73,207, 73,940. Okay, so there's my table of values for years 1 through 4. So we'll add our expressions. So y1 tilde is approximately mx1 plus b. So again, here are your parameters. M equals 788, so your rate of change is 788. And your y-intercept is 70,944. So that's your linear model. Now it's asking you for a 5-year forecast. So same thing, you are going to insert 5 into this linear function. So I have here a 5-year forecast of 78,000 or 74,000, 884 students. So interpret the rate of change on your linear model. So again, my interpretation would be the amount of students is increasing by 788 per year. Okay, so the executive staff is trying to focus the number of students in the district in 5 years to decide whether another high school will be needed. They believe if the enrollment exceeds 78,000 in 5 years, they will need to begin design now. Based on your forecast, is this expected? Okay, so do we expect it to be over in year 5? The answer would be no, not in year 5. Okay? So what you need to do then is what you would need to do is do the allocations part and then do the redraw the lines part. Okay. So like I said, this entire thing will be due on Friday. So manage your time accordingly. Like I said, on Wednesday, we're not supposed to give you work because of the science check-in. So it's your choice if you want to work on this Wednesday or not and be done early. But I will expect to see this uploaded to Canvas on Friday. As always, please, 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 if you have any questions, please feel free to contact me by email or you can meet me on Google Meet. All right, have a great day, everybody, and I hope you do well on your science check-in tomorrow.